Hi, I'm Alan Zhao from MIT. In this video, I will introduce our work titled FingerSLAM Closed-Loop Unknown Object Localization and Reconstruction from Visuo-tactile Feedback. FingerSLAM takes two inputs, a global RGB image that looks at the whole object and a local tactile patch, which captures fine details of the texture. Without the need of any other domain knowledge such as the CAD model of the object, FingerSLAM estimates poses and rebuilds the shape just from the movement of the finger. And here is our hardware setup. We use a gel-set wedge high-resolution tactile sensor at the fingertip, and a RGB camera mounted on the side. Also, an optic track system to capture the ground truth poses. Let's go back to our cube object. What kind of a position were we able to achieve with this particular object? We overlaid the finger trajectory that was captured from our motion capture system here. And this is what our predicted trajectory looks like. The median error is only 2.2 mm in position and 2.1 degrees in orientation. More importantly, error does not accumulate too much. Here's the reconstructed shape for this letter cube. Despite small misalignments in certain areas, the reconstruction looks pretty close to the original shape. So, how did we achieve all this? We built FingerSLAM with a giant vector graph, which combines the outputs from multiple pose estimators. It takes the input of all the noisy inputs, analyzes the credibility of each of those based on a Gaussian error model, and produces a final optimized best estimate. At each time step, the system is given an observation which includes the RGB image and the tactile depth image. The objective of the optimization is the 6 degrees of freedom pose of the object at all time steps. We built two odometry pose estimators that estimates the delta movement of the object between two consecutive time steps, the tactile odometry and the vision odometry. We construct the two odometry pose estimators with neural networks. They both take inputs of images collected at two consecutive time steps and output a delta pose between them. In order to reduce the accumulated error, we also construct a loop closure factor which detects whether the current location of the object has been visited previously. A binary classifier neural network was trained for this. It takes the current observation and previous observation as inputs and produces an output which tells us whether they look at the same spot. We train our estimators on 20 3D printed objects in real world. Evaluations were done with 6 objects that were unseen during training. Our mean error is 2.8 mm in position and 2.4 degrees in orientation. FingerSLAM also achieves highly realistic reconstructions on test objects. For more details, please check out our paper.